Today we are going to start with the O-level mathematics with the topic ratio, proportion, rate, limits, and accuracy and time related to paper 4 of IGCSE and paper 2 of O-levels. And today, what is a ratio? Basically, a ratio will be taken between the two numbers only. There should be the same quantities. Like if you are taking like 1 centimeter, on the other end, there should be centimeter quantity, like X centimeter. It should never be taken in the centimeter and kilometer like that. You will have to take care about that. Ratio means it is the relation between the same quantities over there. And when in mathematics, when we are talking about ratio, it means we will have to go with the simplest number ratio in which all the numbers are not having the common multiples over there. In proportion, we will talk about the directly proportional and inversely proportional over there, in which I can say directly proportional. If one quantity is going to increase, the other quantity should also increase. If one quantity is decrease, other quantity also decrease. That is directly proportional. And in inversely proportional, if one quantity is increasing, other quantity must should be decreasing, and vice versa. Rate. Rate can be taken that if one quantity is changing on the basis of such way that if one quantity is changing, on the other end, other quantity is also changing. Like, for example, you are taking about speed over there. Then I'm saying speed is changing with respect to like distance traveled with respect to time over there. So that is a rate basically. And we can also talk, for example, volume is increasing as I am blowing inside the balloon. Then I'm saying that the radius is directly proportional with its cube over there in case of volume. And that is also a directly proportional relation. It means if I'm changing only the radius, volume is increasing or decreasing over there. After that, limits of accuracy, it will be related to the maximum value and the minimum value, depending upon lower bound and upper bound of the quantity. When he is saying nearest centimeter, it means I will divide 1 centimeter by 2 and then I will subtract for lower bound and for I will add for upper bound over there. One thing more, when I am going to take this relation, for example, I am talking to calculate the speed for that, for upper bound over there. Then in that case, I will say here, distance will use its upper bound and time will use its lower bound over there. Because I need upper bound. In the vice versa, when I need lower bound of speed over there, I will use lower bound of distance and I will use upper bound of time. Then I will get the resultant value over there. On the other end, when we talk about time, always remember that try to count mentally towards the time. Don't go for addition subtraction over there, because in addition subtraction we mostly try to follow the rules of addition of which we have learned in junior classes over there. So we should do mentally, like what is time, like it is 10 a.m. right now. Then we am saying what is the time 6 hours before. Try to count 1 by 1 hour. Don't go to subtract these six from the 10 and get the time. If some minutes are involved over there, can be error over there. It was little bit introduction which I tried to give you, but mainly focus on these questions as a practice question. Try to do the practice questions by pausing the video as you are watching this video. Take the register and pen also, and try to follow the instructions, and then try to solve these questions with me over there. First of all, he is saying the length of rectangle is 17.8, correct to the nearest millimeter. It means this is centimeter. When I'm going towards 1 millimeter, I know 1 centimeter is having 10 millimeters over there, and I am taking its half, and I'm taking 0.5 millimeter, 0.5 centimeter, because 10 millimeter is having 5 millimeter as it's how far it's 1 centimeter it was given in the original quantity. But right now I will have to take 0.5 millimeter. 5 millimeter should be taken according to 1 centimeter. But he is saying go for um, 1 millimeter. Then I will say it will be equals to 0.05 centimeters. 0.05 centimeter I am taking for that. If I take 0.05 centimeter, then if I want upper bound, I will add 0.05 and I will make it 7.85. Otherwise, I will write it 17.75 over there. Correct to nearest millimeter. The width of the photo is 12.7 centimeter to nearest millimeter. And again here, for 1 millimeter and quantity is given in centimeter, I will say it is 0.05 will be the value which I will use for addition or subtraction of lower bound. Here he is saying calculate the lower bound of the area. So it means I will have to take both values with the lower bound because they are showing according to the relation of directly proportional over there. As I know, area is equal to length multiply width. So length multiply width, you should have your calculator with you so that you can put your values easily over there. And when I am using the lower bound of 17.8, then I am saying it is 17.75 because 80 should be subtracted from 5. It should be 17.75 should be multiplied by 12.65. I have used because both of these are directly proportional to the area over there. So I'm taking both the lower bound to calculate the lower bound of the area. If I multiply this, wait a second, 17.75 multiplied 12.65, I'm getting 224.5375. Like this, centimeter square is the area over there. So always try to go for it as it should be solved over there. Let's go for the next one. Here what he is saying over there. He is saying that Kate has a rectangular frame of the length 18 centimeter and width 13 centimeter, both measured corrected to nearest centimeter over there. Okay. Will photo definitely fit into this frame? Okay, photo area is 224. And if I go for 18 and 13 centimeter to be taken over there, I'm taking their lower bounds for both of them. I'm saying that 17.5 centimeter, that is the frame. Okay, nearest centimeter, I'm also going to calculate its lower bound area. 17.5 multiply should be 12.5. I will have to take the lower bound minimum area so that I can maximally I can calculate for that. If I look at these values, it is 17.75, it is 12.65, means this is the big area. So I will say here, by looking at these values, I don't need the calculation to show the area over there. So I can say no, because frame could, no, because frame could measure with minimum lower bounds, with the lower bounds of values 17.5 multiplied 12.5, which is smaller than the photo area over there. I think so you have got it according to this limits of accuracy question over there. After that, he is saying Henrik travels by plane from London to Bangkok. Okay. And when it is 4 local time in London and it is 10 local time in Bangkok. Okay. It means Bangkok is 6 hours before. The flight take 11 hours and 15 minutes. If he leaves London at 2150, means 9:50 at night over there. What is the local time in the Bangkok when he arrives over there? So I will have to go to calculate, first of all, 11 hours and 15 minutes. I should add to 2150. I should add 11 hours. So if I simply say I am going to add 12 hours, let's suppose, because 11 hours, 15 minutes should be taken as like 21. So when I'm taking 12 hours, then it should be uh, 905 over there. And 905, how I calculated this? I'm simply saying here that it is 950. And again, 9 is going to happen in the morning over there. That will be 12 hours because 11 hours and 15 minutes are here. I just add 10 minutes here. Then I get 10, 2200. Then I'm adding 11 hours. It means it is making me to add 11 hours over here. And I'm getting this time towards 9 o'clock in the morning. And then I am adding my remaining 5 minutes over there and getting 905 time in London when the plane will arrive into the Bangkok. But I remember that it is the time which should be taking 6 hours more over there to get for Bangkok over there. So we will have to add our 6 hours. That will be 15, 0, like 9, 9, 3, 12, and then 3. Then it will be 15, 0, 5 over there. At Bangkok will be like this. If he leaves London 9:50, what is the local time in Bangkok when he arrives there? So this will be the arriving time for the question over there. What is the when it is 4 local in 4, then 6 hours forward is for Bangkok over there. Okay. So just look the time differences, that is 6 hour. I have added 6 hours here to get 15:05 is the arrival time inside the Bangkok over there. After that, it is 15:05 over there as the local time over there. Now he is saying on his return journey, Hendrik, Hendrik is leaves Bangkok 7:45 in the morning local time and arrives back in London on the same day at 1:40. Okay, local time. How long does he took for his return over there? Okay, 7:45. Again, 7:45 should be added and got the length of his flight. If he's going for 7:45, it is 1:45, 1:40, according to the London as a local time. Bangkok 7:45. So I will have to go with here the same time. Wait a second. I am going to solve this. On his return journey, Harry leaves Bangkok 7:45 and local time and arrives back in London over there. Okay. So we can say he's reaching here 13:40. Means 1:40 at daytime, 7:45 in the morning. 7, 5, 12, 6. So he should be go for 5 hours and 45 minutes, 55 minutes over there. After that, we can say here length of flight, if I will have to calculate, there was also a difference of 6 hours also there, plus 6 hour, and total it will be 11 hours, 55 minutes over there. So it will be 11 hours, 55 minutes over there. Let's go to the next over there. Here he is saying towards question number 3 that Afzal watched a program that lasted 2 hours 53 minutes. It ended 1:15. What time did it start? Means 2 hours I will have to go for back over there. For 2 hours back, it means it is 1. It is 00 and it is 23. After that, 53 minutes more I will have to go back. So 15 minute back, it means it is going towards 11:15. So it will be like, it means I should say here 0115 is the original time. I will have to go 2 hours back, 1 hour back, 1 hour back. Almost I'm taking 3 hours back. Okay. 3 hours back, the time will be like 20 to 15, like that. And I'm also going towards 7 minutes should be added over there because 53 is there. So I will say it is 20 to 22, like this. Okay. A company paid $250,000 for advertisement that lasted 38 seconds. Calculate the cost correct to the nearest $100 for each second of the advertisement over there. So remember that he is paying 38-second cost for 1/4 of $1 million. 1 million is having zeros with 5 zeros, like that. One with 1, 2, 3, 4, 5, 6 divided by 4. It means it should be go for 25 with 1, 2, 3, 4. $1,000 over there. $250,000 for he is paying for 38 seconds video over there. And now if he is saying go for 1 second cost over there, then it means 2,50,000. 50,000 over 38 should be taken. 125,000 divided by 38. So he is giving 6,578. 6,578 point something like that. And I can also write it like 66,000. Okay. 66,000 over there. 100 over there for 1 second video for promotion over there. The program showed an athlete running 100 meter, measured correct to the nearest meter. Okay, 100 meter, it means it should go for upper bound and lower bound over 0.5 because 1 meter is the nearest. So 1 divided by 2 is 0.5 meters over there. He is saying the time the athlete took is 11.3 seconds, measured correct to nearest 0.1 second. So I will have to go for calculation over there. Then I am saying, he is saying calculate the upper bound of athlete speed. So speed is equal to distance over time. And I will have to go for upper bound. So for distance, I will use the upper bound over there. Because I told you that it is, if I want upper bound of speed, I will go upper bound of distance and I will go lower bound of time over there. So it will be taken as nearest this. So it is 11.25 should be for time. 11.25. I'm taking lower bound for this and upper bound for distance. It should be 100.5 should be taken over there. Okay, 100.5 divided by 1.25. So the answer is 8.93. 8.93 meter per second over there is the speed for this question. Let's go to question number 4 over there, where he is saying that Trevor has a collection of 54 toys of vehicles, 24 cars, 12 vans, and the rest are trucks. Okay. 54 total, 24 minus 54 minus 24 is 0, 30 minus 12 is equal to 18. So rest of trucks is 18 over there. What is the ratio of the vans over there? So I can take car is 1, second one is van here, third one is truck here. So for all of them, I am saying here that it should be taken as 24, 24 ratio 12 ratio 18. So I know 4 is divisible for all. 4, 6. 6, 4 the 24, 6, 2 the 12, 6, 3 the 18. So 4 ratio 2 ratio 3 over there should be taken. After that, he's saying giving that the driver decides that it is the time to reduce the collection of vehicles. He sells C cars, V vans, and T trucks. Okay. He finds the ratio of the cars, vans, and trucks is now 2 to 1. Okay. Now he is saying that uh, what is he saying? He finds that the ratio of the cars is 2 to 1. Okay. Find the CTV given that or sold at least one of each type of car. Okay. And smallest possible number of the vehicles which he is getting over there. So by the given ratio, if I look this, I have total 54 cars. If I go to sell the minimum number and at least one car I should sell over there, then I'm saying here uh, that what is the smallest possible and what is the least each after and the smallest possible number of the vehicles I will also have to write over there. Okay, I'm saying here just multiply them with 5, multiply with 5, multiply with 5 over there. Then I get the ratio 10 ratio 10 ratio 5. 10, 10, 20 and 5. 25 now, which is the highest values that can be used over there. So, because why I'm saying this, if I go for number 6 there, 6, 6 to the 12, to the 12, 24 and 125, 26, 27. Because if I go for 4 over there, 4 to the 8, 4 to the 8, 4, 1 the 4 over there, then the smallest possible number of vehicles is not possible over there. So at least one of each type of vehicle I should use. So the minimum number which I should use is 5. If I go for 6, then it should exceed and the numbers reduced will not give me the reasonable amount over there. So for here, I will say that when I go for 10 over there to subtract from 24 over there, and then I'm saying that I'm getting 14 over back. Then I'm going towards 10 should be subtracted from here. 12 minus 10, I am getting 2 over there. Then I am going towards 18 minus 5, that is equal to 13 over there. Remember that how I said this towards the minimum possible value, at least each type of one type of vehicle over there and smallest possible value. Then if I am telling you, if I'm going with 6 like that, then 6 to the 12 is satisfied for 24, it's okay. And if I go for this 2, then it is equal to 12. So it is not possible. Remember that. Try to understand this question first, then go for multiplication and getting the numbers over there. Let's go to the next one over there. Question number 5, he is saying there, a rectangular field, its dimensions 250 meter and 220 meter and 350 meter, each correct to nearest 10 meters over there. Calculate the upper bound of the area. Remember that area is equal to length multiplied width over there. It means I will to have to go for both of them. Nearest to 10 meters, 10 divided by 2 is equal to 5 over there. So I am using upper bound for both of them because they are directly proportional there. So it is 2 to 5 multiply 355. Wait a second. 2 to 5 multiply 355. I am getting 79875. 79875 centimeter square, meter square over there. Let's move to the next question over there. That is question number 6 here, where he is saying over there, Anna drives 45 kilometer to work each day. Okay. Anna drives 45 kilometer to each day. And one day she drives first 25 kilometer at the speed of 82 kilometer. She takes 36 minutes to drive the remaining distance. Okay. Calculate the average speed of in kilometer per hour for the whole journey over there. Okay. 45 kilometer each day at an average speed. So first time I should calculate time is equal to distance over speed. Distance is equal to 82 over 25. So 82 over 25 is the one time. Second time is for the remaining distance is 36 minutes, which should also be added as 36 over 60. Why I divided this 60? Because minutes should be converted into hour first. So the total time I will get by this relation, that will be, wait a second, 82 over 25 plus 36 over 60 is equal to 0.9049. So I'm using 0.9 over here. 0.9 over here. That is my total time. So I know average speed I need over there. Calculate their average speed. I know that the average speed is equal to total distance. That was 45 divided by 0.9. And it should be taken as 49.7 there. So try to understand the question, how should be added, how should be subtracted. For total time, I have taken both of them. This was the time according to the given speed. This is the time which was given, should be converted into hour, and later on will be used over there. Anna's journey is home is 47 kilometer. Anna's journey home is 47 kilometer. Okay. And here he is saying correct to nearest 1 kilometer. One day, her journey takes home 65 minutes, correct to the nearest 5 minutes. Okay. Calculate the upper bound for the speed in kilometer per hour. So speed is equal to distance over time. And I need upper bound for speed. So I need upper bound here. I will use upper bound. I will use lower bound. For upper bound, the distance will be 47 should be increased because it is going to 0.5 add. The nearest 1 kilometer, 0.5 should be added. 47.5 kilometer divided by 5 minutes for 65 minutes. So I will have to use lower limit over there. For 65 minutes, if I take 5 minutes as lower bound, then 5 divided by 2 is equal to 2.5. So 2.5 should be subtracted from it. So I will get here 62.5. And also I will have to get my answer in per hour. So I will divide it by 60, which should be multiplied over here. So wait a second, 47.5 multiply 60 divided by 62.5. So the value is 45.6. 45.6 kilometer per hour. Okay. For question number 7, he is saying a rectangle 20 centimeter by 8 centimeter is cut from a rectangle 28 centimeter by 15 centimeter. Okay. 28 by 15 is cutting by 20 by 8 centimeter is cut. Okay. Each measurement is given correct to the nearest centimeter. All right. Calculate the upper bound of the area. So area of the shaded region. All right. So first of all, I am going towards the rectangle, which is the main area should be taken it. So I am taking upper bound for both of them, length into width over there, 28.5, because I need the upper bound of shaded area. So I'm taking 28.5 multiply 55.5, 15.5. That was my upper bound man total area over there. Now I will have to subtract. So subtract should be taken as when I am getting upper bound, then subtracting value should be taken by its area by the lower bound both over there. That is 19.5 multiply 7.5. Wait a second. If I am going towards it, 28.5 multiply 15.5 bracket close minus 19.5 multiply 7.5 bracket close. All right. 295.5. 295.5 should be taken. Always remember that when you are subtracting something, then take its lower bound both. And when you are taking upper bound for the area, get the upper bound for your positive value over there. Let's move the question number 8 over there, where he is saying, Naseem drives a total of 800 kilometer on holiday. Okay. He uses total of 29.6 liters of fuel. Calculate the average rate of the fuel in liter per 100 kilometer over there. Okay, so 800 kilometer, for 800 kilometer, he used 29.6 liter. For 1 kilometer, he will use 29.6 over 800. For 100 kilometers, which he is saying per 100 kilometer I need. So I will say just multiply with 100 over there. Two zeros cancel. So 29.6 divided by 8 is giving me 3.7 liters over there. Let's move the question number 9 over there. Here he is saying the graph is the graph shows the cost in dollars of buying a length of fabric in T meters long. Use the graph to find the cost of buying 3.8 meter fabric. Okay, 3.8, 3.5, 3.6, 3.7, 3.8. 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8. Okay, from here I will have to move towards this point. Then I will share here. It is having the corresponding value which is should be added over here. That is 28 should be taken over there. That is $28 over there. So this is the corresponding value which we should take for this purpose.